So now we have the quotient property for exponents. So when we multiplied and the bases were the same, we added the exponents. So think about, what if we had a to the m divided by a to the n? Well, we're going to do this in two parts. Let's assume first that m is greater than n. If that's the case, so if your exponent in the numerator is higher than the exponent in the denominator, the bases are the same, then we're going to have a to the m minus n. So when we multiplied, we added exponents. When we divide, we subtract the exponents. But what if m is not greater than n? So let's say you have a to the m over a to the n, but n is greater than m. So this time the exponent in the denominator is more. Well, then that's going to equal 1 over a to the n minus m, because you're going to have more left over in the denominator. So if you think about it, let's say you have x to the third over x. Well, one of those x's would cancel with one of those x's, and you'd just get x squared. That's the first case. But let's say you had y to the fourth over y to the fifth. Now you've got more y's in the denominator, so you're still going to cancel, but you're going to have a 1 up in that numerator, 1 over y. And how did you get y? Well, it's 5 minus 4. Okay, so if you think about canceling, that might help a little bit. That's how I usually think about it. This just came up the other day. Someone had a question, a student, and they didn't know why there was a 1 in the numerator. But that's because it's all in the denominator there. Okay, so let's go to some examples, and that might make it easier. So our first example, you have x to the 15th over x to the 10. Then that's going to equal x to the 15 minus 10. Now you don't have to write that step out, but you can. And that's going to be x to the 5th. No problem, you have more x's in the numerator, so it's just going to be x to the 5th. Next example. Now notice that this has a base of 6. That's okay. Sometimes the bases are variables and sometimes they're numeric bases, but the rules still apply. They both have a base of 6. You always want to check that. And the numerator has a higher exponent, so it's going to be 6 to the 14 minus 5, or we wouldn't leave it that way, not or, 6 to the 9th. Now, that is a number, but it's a really big number, and I'm not going to figure out what it is. So in general, if the exponents are fairly small, we multiply them out. But if they're huge, we're just going to leave it, like in this case, 6 to the 9th. Okay, now, letter C. So now we have more in the denominator. I still have the same base, x and x, but there's more in the denominator. So it's going to be 1 over x to the 22 minus 18. Now, I've written my base a little bit bigger so you can see the exponents hopefully clearly. So that's going to be 1 over x to the 4th. And that's how you would leave it, just like that. Okay, it's not x to the 4th, it's 1 over x to the 4th. Okay, that's an important distinction. And our last one here, we have the bases the same. This time it's 12. There's more in the denominator, so it's going to be 1 over 12 to the 30 minus 15, or 1 over 12 to the 15th power. Now that's going to be 12 to the 15th is a large number, but because it's a fraction, it actually will be a very small number. We're just going to leave it like that. Okay?